Okay, before we begin example 24 and 25, actually we're going to skip 24 and go straight to 25 because 24 and 25 are very similar and there's no reason to do this problem twice. I want to refer you back, and on the screen here you see this set of notes down here. The part in blue at the bottom is the most important. You can find these two definitions. You were asked to write these two definitions down back on page 12. So back on page 12 of your notes, this is going to become very important here, this whole concept, heat of fusion and heat of vaporization. So something in a word problem says something undergoes heat of fusion. That tells you that it melts. So it's going to be, for instance, solid water going to liquid water. So you have to know that that's a change without being told and given a visual of that. Or heat of vaporization, it goes from liquid to a gas. Okay, so if it vaporizes, it goes to a gas. If it's fusion, it goes from a solid to a liquid. Okay, so that's going to come into play here when we get to the next example. So we're going to skip 24 and go to 25. Okay, so this part in red you aren't given. I'm going to show you how you get that. So give me just a moment here. Liquid toluene, C7H8, a common solvent used in paint thinners, burns in oxygen. So if something burns in oxygen, you can assume it to be a combustion if it's a hydrocarbon. So we have a hydrocarbon, okay? The heat of formation of liquid C7H7 is 12 kilojoules per mole. What is delta H for the reaction of gaseous, so we know liquid, gaseous toluene, taking the heats of vaporization of C7H8 and liquid water being 36.1 and 44.0 kilojoules respectively. Okay, this problem is going to combine two things, what we just learned in Hess's law. Okay, so let me show you what I mean. This is what we're trying to, based on this problem, notice I have gas, 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 and gas. This is what I'm trying to find delta H for. Okay? What we know that the heat of formation of C7H8 liquid, or really this probably should say heat of combustion, would be C7H8 liquid going to 9 oxygen gas going to 7 CO2 gas plus 4 H2O liquid. Now you're asking yourself, maybe saying, I know that it has to be liquid, and I know that normally a combustion is going to form gaseous oxygen, gaseous carbon dioxide, and liquid water unless we're told otherwise. So I know that when it's the liquid phase, unless I was told otherwise, which we're not told anything, we have to assume that we're going to have oxygen in the gaseous phase, carbon dioxide in the gaseous phase, and liquid. So we know this reaction produces 12 kilojoules of kilojoules per mole of heat. We also know, taking into account of heat of vaporization, C7H8 liquid vaporizing to C7H8 gas produces or creates 36.1 kilojoules. So we know delta H for this is that. We also know H2O liquid going to H2O gas creates 44.0 kilojoules for delta H. Okay, we know that because we know heat of vaporization, first of all, takes us from a liquid to a gas, and it tells us taking the heats of vaporization for C7H8 liquid, so that means liquid to gaseous C7H8, because heat of vaporization means go from one state of matter to another, and the vaporization of liquid. Okay, so now we have an A, a B, and a C, for which we can apply Hess's law to get this. Okay, so I want gaseous carbon dioxide to be first. Carbon dioxide, let me try that again, I apologize. Gaseous C7H8 to be first. So that means that I'm going to look at A, I'm going to say, what in A do I need? Well, I need oxygen to be on the side of A, carbon dioxide and water to be on the same side they're currently on. So I'm going to keep it forward, and I'll multiply by 1, because I have 9 and I need 9. So we're going to take C7H8 gas plus 9 O2 gas going to 7 CO2 gas plus 4 H2O gas is going to give me a value of, I apologize, I did that wrong, C7H8 let me start that again. I accidentally looked at red. I shouldn't have done that. So let me erase and let me go back and fix that because that is not what I wanted to do. I was copying my unknown instead of my A. That is a very easy mistake to do. That's why I made it red, but that didn't help. Okay, anyway, so what I meant to copy was A. So my A is going to be C7H8 liquid plus, I'm copying my A, 9O2 gas. That part was fine. Going to 7 CO2 gas plus 4 H2O liquid, because I'm looking at my A, and that's going to be 12.00. It's going to stay forward because it's going to stay positive because I kept it forward in 1. Okay, so now what in B do I need? Well, I need, in my unknown, I need this to be on the reactant side. So I have to reverse B, and I have to multiply by 1. So I'm going to reverse it. C7H8 gas going to C7H8 liquid, and this is going to become, pardon me, negative 44 point, not 44. Got to grab the right number. Let's try that again. Negative 36.1. Because I reversed it, B, I got to change the sign of B. I multiply by 1 so the numeric value stays the same. Now, what part of C do we need? Well, we want gaseous water. So currently, water as a gas is on the correct side. So I'm going to say C, I'm going to keep it forward, but I need 4 of them. So I need to multiply by 4, right? So it's on the correct side, right? It's on, in C it's on the product side, and in my unknown it's on the product side. So just like when we did Hess's law, we're going to keep it forward and multiply through by 4. So it's going to be 4 H2O liquid going to 4 H2O gas. So then that's going to be 4 times positive 44.0. Now let's make sure everything falls out of our A, B, and C, as we will with Hess's law in the past, and make sure it cancels out. So liquid C7H8 cancels because it's 1 to 1, and 4 liquid waters cancels with 4 liquid waters, and then I have left C7H8 gas as one of the reactants, 9O2 gas as another reactant, 7 CO2 gas as a reactant, and 4 H2O gas as a, I'm sorry, I said 7 CO2 gas as a product, and 4 H2O gas as a product. So basically what I'm saying is I have the reaction in blue that's left down here is what I have in red. So now I'm going to just sum these and add them up. So I'm going to take 44 times 4 to get that new number, and this ends up being 176. So I'm going to take 12 plus 36.1 negative plus 176, and I get a total of 151.9 kilojoules per mole. Okay, so 151.9. I want to see if that matches up to what I got before. Give me just a moment to verify that. Yep, matches up, and I would definitely even recommend that you put a positive here because we know it's positive, but that way you know you didn't forget to put your negative sign. Okay, so that concludes all our examples. Now you are going to do the problems assigned on the agenda. Reach out if you need help.